Hi, this is lesson number 18 on pH. We're going to continue talking about acids and bases. Okay, so this is posted on May 15th, so just a few things on the schedule. If you're watching it on May 15th, homework number 15 is due, but most of you will be watching it next week over the weekend. Homework 16, 17, and 18 are all due next week. This one is on sapling, due May 21st. Next week and today, everything on Zoom is office hours. Use office hours. Use SI, which is on Monday, Wednesday from 4 to 5 p.m. to understand equilibrium. Equilibrium is tough. I know that. Nimrod knows that. We're there to help you. Okay, so let's do a little bit of a review of acids and bases. So acids donate protons. That means they lose protons. And bases accept protons. And by protons, we mean H+. And so if I have an acid, right, and it loses H+, what I'm going to be left with we call a conjugate base. And so the reaction with acid plus water, that's Ka. That's called acid ionization. For bases, if they react with water, we call this base ionization. And what happens is the base gains an H+ to become a conjugate acid. And the water has lost H+, so that means it's now OH-. This is base ionization, and seeing that it's equilibrium reaction, we can classify this by a Kb, with the B standing for base. All right, so let's look at a reaction we have down here. ClO4- plus H2O goes to form HClO4 plus OH-. So let's think about that ClO4-. What's happening to that ClO4-? Is it gaining or losing an H+? Well, it's not losing H+, because it never had it, right? If I can't lose $1 billion because I don't have $1 billion. So instead, what's happening? It's actually gaining an H+. That makes it a base. Okay? Gaining an H+ makes it a base. And what it becomes, we call a conjugate acid. The H2O, meanwhile, it starts off with 2 hydrogens. It becomes OH-, so it lost one. So that means it must be an acid. And that makes OH- my conjugate base. Okay? Let's look at this second problem. In the second problem, we're asked about what is the conjugate base of H2SO4. Okay, so if we think about H2SO4, we want to know its conjugate base. So that means that H2SO4 must be an acid. Acids produce base, base produce acid. All right, so it's going to go, and it's going to react, and it's going to form a conjugate base. Okay? Always remember, what do acids do? Acids lose a proton. So if it starts off as H2SO4 and it loses a hydrogen, that means it's HSO4. And because it lost H+, that means that my HSO4 is now going to be negative. So HSO4 is my conjugate base. Okay? All right. So that was a review from last time. Now we're going to talk about water. Water is pretty important. We know this. You'll study it in biology a bunch. We need water to survive, right? Well, another cool thing about water is that water can act as either an acid or a base. We saw this last time, especially in the problem video. But look at these two reactions. If I have Cn- plus H2O, right? The hydrogen can be stolen from or can be lost by the H2O to go to the Cn-. So that means that here, H2O is donating an H+. That makes it an acid. In the second one, HBr loses an H+, whereas H2O gains an H+. That makes it a base. So it can be both an acid and a base. And in fact, if I have two water molecules, like at the bottom, one of those water molecules can steal an H plus from the other one. This will form H3O plus and leave behind OH minus over here. Okay? This is called autoionization. Okay? We talked about acid ionization and base ionization earlier. That's a base plus water. Autoionization is the reaction of water and water. Okay, so here's another diagram of it. You have one H2O gaining an H plus to become H3O plus. You have one water losing it to become OH minus. That means this water over here on the left, that's a base, and this is an acid. Okay? We can write this, for simplicity, as just H2O liquid going to form H plus OH minus. Okay? It is an equilibrium reaction. Okay? Now, this doesn't happen a lot. Okay? For instance, in 100 mLs of water, so about a glass full, there are 3 times 10 to the 24 H2O molecules. There are a lot of those little molecules floating around. Only 6 times 10 to the 15th will dissociate. That's still a big number, but if you compare them, that means only 0.0000002% of those water molecules are going to dissociate. All right. Now, because this is an equilibrium reaction, we can write a K for it. And the K is going to be my concentration of H plus times my concentration of OH minus. Okay? Notice water isn't in there because it's liquid, so we don't include this in our K. All right, this is known as Kw, or the water self-ionization constant. Remember last class we talked about Ka, that's for acids, Kb, that's for bases, and now Kw is for water. All right, now, at 25 degrees Celsius, this Kw is 1.00 times 10 to the negative 14. That's actually really nice because it's a nice round number. Okay? If we were at a different temperature, it'd be a different value. But at 25 degrees C, which is what we'll do 99% of the time in this class, it's equal to 1 times 10 to the negative 14. Okay? Now notice, this is very small. What does that mean? Seeing that K is products over reactants, I'm not going to get much of H plus and OH minus out there. This Kw actually increases with temperature. If I was at 100 degrees C, boiling water, it would be 6 times 10 to the negative 13. Not a lot higher, but a little bit higher. Okay? All right, but we're only going to use this value right here. All right, let's think about something. If I have pure water, what that means is that my concentration of H plus and OH minus will be constant. The reason being is if all I have is H2O, right, and it dissociates, it's going to give me equal amounts of H plus and OH minus. Okay? So if I replace these with X, what that means is Kw equals X squared equals 1 times 10 to the negative 14. I could then take the square root of this, and I get that in pure water, that's the key, H plus and OH minus equal 1 times 10 to the negative 7th mole. Okay? These are key points. We'll talk about them over and over again, right? We have this water self-ionization. We have this reaction right here. And then we are told that in pure water, H plus OH minus equals 1 times 10 to the negative 7. Okay? Pure water is what we call neutral. Neutral means I have equal amounts of H plus and OH minus. Okay? In the same way that, if I'm talking about Star Wars, I have neutral or I have balance to the Force if I have the same number of Sith and Jedi, right? Same number of good and bad, right? I have the same number of H plus and OH minus. That's neutral. Okay? Now, because we have this reaction, what happens if I add acid? Well, if I add acid, I'm going to get more H plus. That's because that's what acids do. Okay? So if my H plus increases, my OH minus must decrease. Okay? The reason being is that H plus times OH minus equals some constant. So if H plus increases, OH minus has to decrease. Okay? Let's say instead I add base. If I add base, what's going to happen is my OH minus is going to increase. And in that case, my H plus must decrease. Okay? I have down here, why is this the case? The reason this is the case is because of everyone's favorite Le Chatelier's principle. Right? Le Chatelier's principle says, if I add a product, such as OH minus, what happens? It shifts towards the left. That means I'm going to get less of my H plus. So my OH minus will increase, but my H plus is going to decrease. Okay? And vice versa for if I add H plus. Okay? Let's look at this. Let's use this KW in a problem. Okay, let's say we have a solution, and we're told that, or we always know that KW equals H plus times OH minus. Okay? And we're told that this solution has a H plus concentration of 2 0.0 times 10 to the minus 7, right? And we want to know what is the concentration of OH minus. All right, so we can use this equation because remember at 25 degrees, KW equals 1 times 10 to the negative 14. We don't even have to include the times at 25 degrees. We're only going to use it at that. All right, so if that's the case, I could go ahead and rearrange this. I want to know OH minus, so what I'm going to do is I'm going to divide by the H plus. So that's going to be KW over H plus. Okay? So that would be 1 times 10 to the minus 14th over 2 times 10 to the minus 7. All right, now is where you have to get your calculators, and we need to make sure we're doing this right. If you had me for 215, when we got to the chapter on light, I said, make sure you understand it. And that's because we need to make sure when we put this in the calculator, we use parentheses. Okay? Otherwise, what it'll do is it'll take this number, divide by 2, and then it's going to multiply that all by this number. Okay? If you do not get the same number I get right now, go ahead, get on office hours, get to SI, and ask, and we'll look and we'll make sure we understand how to calculate. Okay? All right, so I'll show you on my calculator. So I have 1 e to the negative 14th. I go ahead and I divide, and on my calculator I can do 2e to the negative 7th, and I get 5e to the negative 8. 5 times 10 to the negative 8. Okay? This is molar because it's concentration. All right, some of you may not have this EE button, so what you have to do instead is you do 1, let's clear, sorry. You can use parentheses. So I can do parentheses 1 times 10 to the, let's see, what do I want to do? Negative 14. Okay, there's that. Divided by parentheses 1 times 10 to the negative 7th. Oh, sorry. It's 2 times 10 to the negative 7th. All right, sorry. I do parentheses 1 times 10 to the negative 14th. and then I divide by, in parentheses, 2 times 10 to the negative 7th. I close that parentheses, and I get 5 times 10 to the negative. Okay? Be very careful. Make sure you know how to use the calculator. Notice I had never used that way to do it. I always just use EE, so it was tough for me. Okay, so on the screen is how we did it. We rearranged that equation to get OH minus in terms of H plus and KW. So this is KW over H plus. I plugged everything in and I got my answer. That is for my OH minus. All right, I have 2 more problems that you're going to do as part of video problem 18A. In one, you're told OH minus and you have to calculate H plus. And in the other, you give an H plus and you have to calculate OH minus. Okay? The order and the way you do this is very similar. All right, so we're going to move on, and I'm actually going to, on the next page, give you the answers to this. All right, so if OH minus is 1 times 10 to the negative 10th, what we end up with is 1 times 10 to the minus 4th for my H plus. And if H plus is 12.5 molar, we end up with 8 times 10 to the negative 16 molar for my OH minus. Okay? So I have these answers here, H plus on the left, OH minus on the right, right? So this is what we did on the screen. These are what you're going to do in those 2 problems. Okay, so let's look at this. On the left-hand side, I'm increasing my H plus, right? I'm going from a very small number to a bigger number to a fairly big number, okay? What happens on the right-hand side? As my H plus increases, going down, well, my OH minus actually is getting smaller and smaller, right? 10 to the minus 8, 10 to the minus 10, 10 to the minus 16. These are getting smaller and smaller, okay? So as H plus increases, my OH minus decreases. Okay, so now, notice all these numbers. Usually we don't have H plus concentrations like this big. This would be an acid that you put on your finger and you have to wash it off instantly. Usually we're dealing with very small numbers. So how do we deal with this? We deal with something called potential, which we label as P. Okay? So I can take Px, which is the potential of any compound X, and I say this is equal to negative log of X. Okay? We're very common, we know one of these, and that's pH. pH is the negative log of the H plus concentration. Okay? We use this all the time in chemistry. We say something's an acid or a base based on its pH. We'll talk more about that. We also have something similar called pOH. We don't use pOH much. In fact, we just use it for calculations. It's a little easy, but usually we just use pH. And we'll talk about how these are linked. Okay, so pOH equals negative log OH minus. Okay, so I take the concentration of OH minus, take the log of that, and then make it negative. Okay. Now remember, in pure water, we said that H plus was 1 times 10 to the minus 7th. If I put 1 times 10 to the negative 7th in my calculator, I take the log of that, I get negative 7. Okay, sorry, let me just show this. So I take 1 EE7 negative, I take the log of that, I end up with negative 7th, and then I take the negative of that, I get 7. I can do the same thing for pOH, okay? And notice that I get pH of 7 and pOH of 7. This is in pure water, or what we call neutral. Okay, so these are those values or these are just some values for H plus. If I had 1 times 10 to the negative 1, my pH would be 1. If I had 1 times 10 to the negative 4, my pH would be 4. 1 times 10 to the negative 10, pH 10, right? And 14. Right? This is basically just the definition of what pH is. We could also do pH for something that's not a nice round number. Like let's say we had 2.5 times 10 to the negative 10. If I want to figure out its pH, I can do the log of that. I get negative 9.6. And so I take the negative of that and I get 9.6. Okay? All right. So this is our pH scale. Okay? The larger the concentration, like we had 12.5, it would have a negative pH, right? As our concentration, actually, let's go back and just think. So let's look at this scale. As my concentration gets smaller and smaller, my pH actually increases, okay? Typically, we think of pH as ranging from 0 to 14, where 0 would be acidic and 14 would be basic. We can actually get things higher than 14 or lower than 0, right? For instance, 12.5 molar, we'd get a pH of negative 1.1, right? If I had 1 times 10 to the minus 16th molar, that'd be a pH of 16, okay? But these are very rare, okay? Now, this is the pH scale, where 7 is neutral, okay? That means I have equal amounts of H plus and OH minus. That's pure water. Okay? Anything below 7 means it's acidic. Everything above 7 means it's basic. So we have things like milk and seawater. These are things very close to pH of 7. You know, if I have milk on my hand, I don't go ouch, 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 right? Or seawater, hopefully not, right? But if instead I put lemon juice, right, and I had a little cut, it'd start to sting. That's because it's acidic. Or if I just had my hand normal and I put battery acid on it, I'd really notice it, right? Same thing goes for things like baking soda. Baking soda, if you put some water on it, it kind of feels slippery, right? That's the OH minus. That's the basic nature. But if you put bleach on it, you actually would really feel pain, and bleach would actually also bleach your clothes, right? All right. Usually we're between 0 and 14. We can actually get things that are even more. You know, if I had concentrated hydrochloric acid or concentrated sodium hydroxide, a base, we could get pH negative 1 or pH 16. These are very rare, though, right? If you're dealing with these, you have to be very careful in the lab. Okay. All right. So that's the pH scale. So let's go ahead and let's think of those ones we had earlier. So we had 2 times 10 to the negative 7th molar H plus. We calculated the OH minus associated with this. Okay. If I calculate the pH of this, I get 6.7. My 1 times 10 to the negative 4 molar H plus would be a pH of 4. And my 12.5 molar H plus would be negative 1.1. Now, that's my pH. Okay. I can do the same thing with my OH minus. And this would give me POH. So if I take negative log of 5 times 10 to the negative 8, 10 to the negative 8th, on my calculator, I get 7.3. Right? This is just log of, or actually I get negative 7.3 for the log. And then I take the negative of this, I'll get 7.3. Okay. That's my POH. I can do that for the others. I'll get POH of 10 and POH of 15.1. Okay? Notice how these are linked. Okay? My pH is 6.7. My POH is 7.3. If If I add up those two numbers, I'd get 14. If I had a pH of 4 and a pOH of 10, I'd get a sum of 14. If I negative 1.1 and 15.1, I'd get a pH or a sum of 14. So pH plus pOH equals 14. All right. Now there's one other thing. Notice we say pH equals negative log of H plus. Well, what happened? That's great if I want to find pH. Let's say I wanted to find H plus. Well, I can find that based on my pH. So I can go ahead and I can say negative pH equals log of H plus. Okay? And the opposite of log is to do 10 to that power. So 10 to the negative pH equals 10 to the log H plus. If I take 10 to the power of a log, what I end up with in this case would just be H plus. This isn't my best work on writing with the thing. And that's this equation here. Okay? All right, so all these equations we can use in order to change between H plus and OH minus and pH and pOH, etc. Now this is only at 25 degrees C, but as I've said multiple times, we only care about 25 degrees C. Okay. Now remember that we said acidic is pH less than 7, basic is pH greater than 7, then neutral is only at pH 7. Okay? So we can look here and we can say, all right, we have neutral here, that's equal amount of H plus and OH minus, pH 7 and pOH 7. If I get more acidic, okay, my pH decreases, my concentration of H plus increases, and my concentration of OH minus decreases. Okay? If I go more basic, okay, what happens? My pH increases, my concentration of H plus decreases, and my concentration of OH minus increases. Okay? We also have information on pOH here. Usually we don't use pOH that much. All right, let's go ahead and let's use this a little bit. All right, so what we're going to do here is we're going to start to fill out this table, and then you're going to fill it out for cases 2, 3, and 4. All right, so let's do the first one. So we're told that pH equals 8.2. So if I know pH, I can calculate H plus, I can figure out pOH, and I can figure out OH minus, because they're all linked together. All right, so pH equals 8.2. Let's say I want to figure out H plus. How can I figure out H plus from pH? Well, if I look at the top there, I have that top equation, Kw equals H plus and OH minus. That doesn't have pH in it, so I'm not going to use that. I have pH plus pOH equals 14. I'm not going to use that because it doesn't have H plus in there. Okay? We have pH equals negative log of H plus, and we have H plus equals 10 to the negative pH. Okay? We could use either one of those to figure out H plus. The values with pOH, those we can't use because they don't have pH in there. All right, so which one am I going to use? I could use either one because in reality these are just the same equation rearranged. Okay, but which one am I going to use? Well, I know pH, so if I use this second one, I can just plug that in right away to get my answer. Okay, so I take negative 8.2 On my calculator, I do second 10 to the x, and I get 6.3 times 10 to the negative 9. Actually, if you do this on some of your calculators, you might get this answer, right? 0.000000006. Okay? These are the same number, but this is a horrible way to write it. We always want to use scientific. So you should know on your calculator, and I'll show you on mine. If you want, we can look at your calculator and try to figure it out. I can do the second and see right above the 5 where it says psi. I'm going to push that, and that goes ahead, and that turns that number into scientific. All right, so this is my H plus. Okay, so I figured out H plus. I also want to figure out POH and OH minus. Well, if I know H plus, I should be able to find OH minus. We did this earlier, right? Because remember, KW equals H plus times OH minus. We know KW, it's at the top of the screen. We know H plus, so we can figure out OH minus. So in this case, my OH minus is going to be KW over H plus, which is 1 times 10 to the negative 14th over 6.3 times 10 to the negative 9. Okay? I'm taking a very small number, dividing by a slightly bigger number, so I should get a small number. Okay? 1.6 times 10 to the negative 6. Okay. So notice how I can get these two and I can figure it out. All right, the last thing we want to do is we want to find POH. There are actually two ways to find POH. I can either use this one to calculate POH using the equation up there, POH equals negative log of OH minus, or I could use that, pH plus POH equals 14, right? So if that's the case, POH equals 14 minus pH. That's 14 minus pH, or sorry, 8.2, or 5.8. Okay? pH and POH don't have units. I don't put 5.8 pH. I just say the pH is 5.8. Okay? All right, so I started off with pH, and I was able to find H plus, OH minus, and also POH. Okay? So is this acidic or basic? We should be able to tell whether it's acidic or basic based on any one of these numbers. Okay? If my pH is greater than 7, that means it's basic. If my H plus is less than 1 times 10 to the negative 7th, that means it's basic. If my my OH minus is greater than 1 times 10 to the negative 7th, and this number is, right? Because remember, 10 to the minus 6 means 0.00016, whereas 10 to the negative 7th, you have more zeros, right? So if this is greater than 10 to the negative 7th, that means it's also basic. All right, so let's go ahead and look at this, right? So all of these point to the fact that this is a basic solution. All right, so you're going to go ahead and you're going to fill out the rest of these. Each one, you're given different information, right? In one case, you're given H plus. In another, you're given POH. And in the other, OH minus. You're going to use these equations to figure that out. By the way, at the end of this section, I'm going to have a little chart that is really helpful for doing this. All right, so let's just talk a slight bit about pH. Okay, now pH is what we use all the time. You've used pH before you even knew what it was. Okay, we use pH. We usually don't use pOH. Okay, it's just not needed. What does a pH mean? So we have pH paper. We'll explain how this comes about later. Right? But here we can see there's a solution, and we have a pH of 1 based on the color. Here we have a pH of 3. Okay, it's orange, so it's 3. What does this mean? This means that my H plus is 1.1 times 10 to the negative 1 on the left one, and 1 times 10 to the negative 3 on the right one. Okay, so this one has 100 times more H plus. Okay, so each change in pH of 1 means a difference in concentration of 10 times. Right? This is why something with a pH of 1 versus something with a pH of 4, 1 is going to be very acidic, and you have to be careful. 4, you don't have to be as careful with, right? Wine versus, the juice in your stomach, or the acid in your stomach, right? So even though it's a small pH difference, that's a huge change in concentration, right? Okay, so that is it for pH, right? We talked about neutral. Neutral means pH is 7. Anything other than 7, it's not neutral. If it's neutral, that means H plus and OH minus are both 1 times 10 to the negative 7th molar. These are concentrations. Okay? If it's acidic, that means my pH is less than 7, which means I have more H plus and less OH minus. If my pH is greater than 7, that means it's basic, and that means my H plus is less than 1 times 10 to the negative 7th, and my OH minus is greater. Okay? We have these equations down here that relate H plus, pH, pOH, and OH minus. Know how to use them all, right? And one of the key things is this water ionization, right? Which has a KW of 1 times 10 to the negative 7. Okay? This is that chart that I talked to you about, right? If you have a pH, you use this equation to get H plus, and then you can use this equation to get OH minus. If you're given H plus, you can use this equation to get to pH, and you can use this equation to get to OH minus. If you're given OH minus, you use this equation to get H plus, and then you use this other equation to get to pH, this equation down here. Right? So you're all linking them together. Notice I didn't include pOH, because I don't actually like using pOH. It kind of makes sense to use sometimes, but these are typically what we're going to use. pH, H plus, and OH minus. All right, so that is it for lesson number 18. Remember, the homework for this will be on sapling, and this is all about acids and bases. We're going to be dealing with acids and bases for another 2 weeks. So, make sure you understand this. Come to office hours, come to SI, and let's figure this out. All right. Bye-bye.